This video is for section 3.3, real zeros of polynomial functions. It's the day 2 lesson out of 3 days. First, let's review the day 1 concepts and skills, since I'm not going to be in class to review this with you or help you on the homework if you had questions. Learning goal 1 from our last lesson was to understand that zeros of a polynomial are connected to the factors of a polynomial. Here's an important concept. If x equals a number is a zero of polynomial f of x, then x minus that number is a factor of the polynomial. Here's an example. A polynomial function has 3 zeros, -2, 0, and 3. Write an equation for that polynomial in factored form. We're going to write f of x equals, and then instead of writing the polynomial in standard form, we'll write it as factors multiplied together. This has 3 zeros, so there are 3 factors multiplied together. If -2 is a 0, then one of the factors is x plus 2, because -2 plus 2 would make a 0 in that position. If the number 0 is a 0, then x take away 0 is a factor. And if the number 3 is a 0, then x minus 3 is a factor. If we wanted to create standard form for f of x, we would use FOIL repeatedly until we got this as a list of terms. Learning goal number 2 from the previous lesson was to be able to use long division to find a factor of a polynomial when given a factor to start with. Here's the key concept. If x minus a is a factor of a polynomial, then there must be another factor, let's call it q of x, that multiplies to the x minus a to produce the polynomial. Here's an example problem to make sense of that idea. We're given that x minus 3 is a factor of this quadratic polynomial. Let's find another factor. Now there are a lot of ways to do this, but the intention here is to practice long division. So we have x minus 3, and that will be divided into, with a normal long division bracket, x squared minus 7x plus 12. Now we have to be careful when writing this polynomial in the bracket that if there were any missing terms, that we include them with placeholder zeros. Like if this didn't have an x term at all, we'd want to, in this position, write plus 0x to hold the position. Now we're going to begin dividing using the normal long division process that you first learned in elementary school. When you do this, focus on leading terms only. Look at the x and look at the x squared. X multiplied by what makes x squared? And that's x, which is written up above, just like you did in elementary school. Then multiply this value up here by this number out in front. X times x is x squared. X times -3 is -3x. This term and this term must match exactly, or else you did not figure out the correct value up above. Now let's use subtraction. X squared subtract x squared makes nothing. -7x subtract -3x is -4x. It's really easy to mess up subtracting, especially if this is a negative, so be really careful with that. You might need to use the calculator. -7 subtract -3 and push enter to see that it is a -4. Then, like normal long division from elementary, bring down the next term. Now we're ready to divide again. Focus on the leading thing here and on this leading term here. X times what is -4x? That makes -4. -4 times x is -4x. -4 times -3 is positive 12. When you subtract, it makes a remainder of 0. If this was not a 0, if there was some other remainder, then up here in this position, you would write plus, you would write down that remainder number, and then you draw the fraction line, and you'd write x minus 3 as the denominator of that fraction. But in this case, the remainder was 0, so x minus 3 divides evenly into that trinomial. The other factor is x minus 4. It said find another factor. It's x minus 4. The third learning goal from yesterday's lesson was to be able to use long division to write a polynomial as a product of two factors plus a remainder. Here's the key concept written in algebra language. A polynomial can be written as d of x times q of x plus r of x. This is the divisor. This one right here is the quotient. And this piece right here is the remainder. These algebra symbols are giving a pattern of the answer that we're looking for. Here's an example problem. Write this trinomial in the form above if we're told that d of x is x minus 2. We're going to do this using long division. We're going to take the x minus 2, which is the divisor. That's why the letter D is used for the word divisor. And we're going to use long division to divide it into our polynomial. Once you have the bracket all set up, now it's time to run through the long division process. X times what makes 2x squared? We need to have a 2x. Because 2x times x is 2x squared. These have to match each other. 2x times negative 2 is negative 4x. Now comes subtraction. These cancel out to a 0. 13x subtract negative 4x is 17x. Then bring down the positive 15. X times what is 17x? That is positive 17. 17 times x is 17x. And 17 times negative 2 is negative 34. Now subtract. Be really careful on this subtraction. 15 subtract negative 34. It makes 49. If you're not getting a 49 here, then you are not subtracting this negative 34 correctly. Use a calculator and go 15 subtract negative 34 and push enter. This time we did not get a remainder of 0. So up here, right in this position, you write plus. You write your remainder on top of the divisor. Okay, here is the result from using long division. We just need to make sure we're following the directions and we're writing it in this format right here. So it says write f of x as this times this plus the remainder. Let's do that. What was d of x? It was x minus 2. We were given that to begin with. What is q of x, the quotient? What did we get when we divided with the long division? We got 2x plus 17. Then this piece right here, this r of x, that's our remainder. What was our remainder? Our remainder is 49. We have rewritten our polynomial as two factors multiplied together plus this additional remainder. If we were to multiply these together using FOIL and then combine like terms with the 49, that would create our original f of x trinomial. Now that we've reviewed the day 1 topics, especially long division, we're ready for today's concepts and skills. Here's learning goal number 1. Be able to divide a polynomial using synthetic division instead of long division. Here's the key idea. When the divisor of a polynomial has the form x minus k, then you can use synthetic division instead of long division to rewrite the polynomial in this form right here that we had just done on our example problem. It's important to realize that synthetic division only works when you're dividing by a number that has this format. If you're not dividing by a binomial that can be written in this form, then you cannot use synthetic division. You have to use long division. Now let's work on an example problem so you can see what synthetic division looks like. The first thing you do is you write down the coefficients of your original polynomial. 2, 5, and 6. The 2 comes from the x squared, the 5 comes from the x, the 6 is the constant term. Then make the synthetic division bracket. which goes upside down compared to the long division bracket. And there's some space below that row of numbers. Next, out in front of the bracket, you're going to put the value of k. So when you look at the divisor, what is the number that follows the subtraction sign? It's a 1. Another way to think about what the value of k is what is the value of x that makes that be a 0? Well, that would be 1 take away 1 is how you'd get a 0. So it's a 1 that you're using out front. Now let me demonstrate to you the synthetic division process. Take this first number 2 and bring it all the way down below the bracket and write it down. Then multiply 2 times the 1 and write the result under the 5. Then add together 5 and 2, making 7. Then multiply the 7 times the 1 and write the result under the 6. And then add together the 6 and the 7, making 13. Synthetic division uses multiplying and adding, unlike long division, which uses dividing and subtracting. Now that we've got this list of numbers written down, we need to interpret our results. The very last number is our remainder. Then these two numbers together end up being the coefficients of our quotient. When I write my answer in the space over here, you'll see what I mean. Remember that what we were doing on this question was to divide this trinomial by this to get the answer. Well, our answer is 2x plus 7 plus 13 out of x minus 1. Do you see where I got the 2x plus 7? It comes from this 2 and this 7. And do you see how I wrote down the remainder? I took this number in this position and I wrote it on top of our divisor, x minus 1. This is the same result we would have got if we had used long division to perform that dividing problem. Let's try another example to see synthetic division again. We're going to divide this 4-term polynomial by this divisor. Because this divisor fits the x minus k format, we're allowed to use synthetic division. So you write down the coefficients of the polynomial. 1 from the x cubed, 3 from the x squared, negative 6 from the x, and then negative 1. Now make that synthetic division bracket. What's the number you're going to divide in? It's the value of k. It's the 2, the number after this minus sign. Now we're going to follow the process. You start by bringing the first number all the way down below. Then you start doing multiplying and adding, multiplying and adding. So 1 times 2 makes 2. 3 plus 2 makes 5. 5 times 2 makes 10. Negative 6 plus 10 makes 4. 4 times 2 makes 8. Negative 1 plus 8 makes 7. The last number is the remainder. These numbers go with the quotient. Remember, this problem was about dividing, so we want to write down what is the quotient. What did we get as an answer? We got 1x squared plus 5x plus 4, and now our remainder, plus 7 out of x minus 2. Notice how the 1, the 5, the 4 become those three numbers. And notice how the remainder is added on the end on top of what you were dividing by. Here's a third example. We're going to do synthetic division again. Here's our polynomial, and here's what we're dividing by. Now remember how you can only do synthetic division if it has the pattern x minus k. So what's going on here? What do you have to think of this as? You have to consider this as x minus negative 1. Now you have the value of k. Again, another way to think about it is, what's the value of x that makes that be 0? Well, x would be negative 1. Okay, let's list our coefficients. 2 from the x to the fourth, 0 from the x cubed, 1 from the x squared, -4 from the x, and then the 2. Notice the placeholder 0 to account for the x cubed. The 0 comes from right in here. It's like having a 0 x cubed in that position. Okay, now I'm going to make the bracket. And the number that's being divided in out front is -1. Okay, we're going to run through the process. Bring the first number straight below. Then start multiplying and adding. 2 times -1 is -2. 0 plus -2 is -2. -2 times -1 is +2. 1 plus 2 is 3. 3 times -1 is -3. -4 plus -3 is -7. -7 times -1 is 7, and 2 plus 7 is 9. That's the remainder, and all of those create our quotient. So here we go. We're going to make our answer. 2x cubed minus 2x squared plus 3x minus 7. Now the remainder, plus 9 over x plus 1. I hope you noticed that on all three of these division problems, when we wrote the quotient down or our answer down, that the first term of our answer had a degree that was 1 less than the degree of the original polynomial. Synthetic division reduces the degree of the polynomial. Okay, we've done 3 examples now where I've shown you step by step how you perform this procedure called synthetic division. Let's summarize the steps of synthetic division. Step 1, write the coefficients of the standard form polynomial and use placeholder zeros if necessary. Notice I said standard form. The original polynomial must have the terms written in that decreasing order of exponent. And if any terms are completely missing, that's where you need the placeholder zeros. Step 2, create the synthetic division bracket and write the value of k in front of the bracket. The value of k is a number. Step 3, bring down the first coefficient. Then begin a multiply and add process through each coefficient. Step 4, once you have the result below the bracket, the last term is your remainder and the other numbers are the coefficients of your quotient. If this process seems confusing, it's because you haven't done many examples yet. I think you'll discover that the more synthetic division you do, that ultimately you'll like it more than long division, because it is definitely easier to add and multiply numbers than it is to try to divide and subtract them. Next, learning goal number 2. Be able to apply the remainder theorem to evaluate a function for a given value of k. Here's the remainder theorem in algebra symbols. If f of x is divided by x minus k, then the remainder is the value of f of k. Let's do an example so you see what this is talking about. Evaluate f of 2 if f of x is this function. But instead of using direct substitution, plugging the number 2 in place of all the x's and finding the answer, we're going to use synthetic substitution. Synthetic substitution is just the synthetic division thing that we've been doing. So write down the coefficients of the polynomial. 3 from the x cubed, 2 from the x squared, -1 is in front of the x, and then +5. Then draw the bracket, and out in front, we're going to substitute in a 2. Now let's follow through the procedure. Bring the 3 all the way down below. Now start multiplying and adding. 3 times 2 is 6. 2 plus 6 is 8. 8 times 2 is 16. -1 plus 16 is 15. 15 times 2 is 30. And adding these together is 35. The remainder theorem says, when you use synthetic division to divide, the remainder is the value of f of k. meaning this remainder is the value of f of 2. We figured out that f of 2 is 35. Do you believe it? Let's do example 1 again, but the old-fashioned way, direct substitution. So we want to find f of 2, and with direct substitution, that means you replace x with 2 in every spot that there's an x. I've taken this function up here from example 1, and for this x, for this x, and for this x, I've substituted in a 2 using the parentheses around it as you're used to doing. At this point, you can talk this through mentally, or you could type it in the calculator. 2 to the third power makes 8, and 3 times 8 is 24 in this position. 2 to the second power is 4, and 2 times 4 makes 8 in this position. Then we have minus 2, and then we have plus 5. 24 plus 8 is 32. 32 minus 2 is 30, and 30 plus 5 is 35. We got the same answer using synthetic division as we did using the direct substitution that we know so much from Algebra 1. Here's a third example. Let's evaluate this function for x equals negative 3. Again, you could do direct substitution, but the intent of this lesson is to practice the synthetic substitution technique. So we have 10 from the x to the fourth, then negative 6, then positive 2, then negative 5, and then the positive 1. Then draw the bracket. What's the number you're substituting in? It's negative 3. Now we're going to run through the process. Bring the 10 below. 10 times negative 3 is negative 30. And add these together. That's negative 36. Then multiply negative 36 times negative 3. That makes 108. And then add these together, making 110. Then multiply 110 times negative 3. That's negative 330. And then add these together, negative 335. Then multiply this number by the negative 3. The result is 1005. And finally, add those last two together, making 1006. That very last number you get is called the remainder, and the remainder is the value of f of negative 3. If you don't believe it, you can take this original polynomial and put a negative 3 here, 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 and type it all in your calculator, and you will get 1006. Now for our third learning goal. Be able to apply the factor theorem to identify factors of a polynomial by using synthetic division to identify zeros of the polynomial. Here's the key idea. F of x has a factor in this format if and only if f of k equals 0. Let's do an example so you see what that really means. We want to factor this trinomial. And to help us factor it, we're going to use the synthetic division technique. So we have 1 from the x squared, 3 from the x, and then the positive 2. Now we want to divide in a number that is a 0 of that function. Now, if you don't know what the zeros of the function are, then it's almost like you're doing a guess and check version of synthetic division, where you're going to guess a number out front, run through the process, and if you get a remainder of 0, then that number that you divided in is a 0. I'm going to divide in 1 and see what happens. Start by bringing the 1 down and then multiply and add. 1 times 1 makes 1, 3 plus 1 makes 4, 4 times 1 makes 4, and 2 plus 4 makes 6. I notice I did not get a remainder of 0, therefore this number is not a 0 of the function, and it doesn't help me to find out one of its factors. Not only did it not work, but I noticed that the results I was getting across the bottom kept increasing. I'm never going to get a 0 when that pattern happens. I think I should have used a negative number out front. So let me erase this, and instead I'm going to try -1 and see what happens. So you bring down the 1 and now start multiplying and adding. 1 times -1 is -1. 3 plus -1 makes 2. 2 times -1 makes -2, and adding these together makes 0. The remainder is 0. What that means is -1 is a 0. If -1 is a 0, that means x plus 1 is a factor. Not only did synthetic division get us one of our factors, but by looking here, we can see the other factor is x plus 2. I submit to you that if you had never heard of synthetic division and I simply asked you to factor that polynomial using FOIL, that you would have got this same answer. So if you already know how to factor a trinomial to get the answer, why would you need to use this new way, synthetic division, to help you factor? Well, you don't when it's something that you know how to factor. But what if it's more complicated, like example 2? Can you factor this? Up to this point in the school year, you have never factored anything that complicated. But with synthetic division, you can factor it. Let's give it a try. 1 from the x cubed, -9 from the x squared, 20 from the x, and then the -12. I did not need any placeholder zeros this time. There were no missing terms. Now I want to divide in a number that I think is a 0 of that function. I don't know what to use. I'm going to try 1 and just see what happens. Bring the 1 down. 1 times 1 makes 1. -9 plus 1 is -8. -8 times 1 is -8. 20 plus -8 is 12. And 1 times 12 is 12. And adding these together, hey, it's 0. The remainder is 0. That tells us two things. The number 1 is a 0 of this function, but it also tells us that one of the factors is x minus 1. Now, what are the other factors? Look right here. We can use these coefficients to know that the quotient is x squared minus 8x plus 12. Our original polynomial went to the 3rd degree, but we've reduced it to a trinomial that's only to the 2nd power. And we can factor this. X minus 6 times x minus 2. The -6 times the -2 is the positive 12, and the outer product and the inner product is the -8x. Here is factored form of this really complicated polynomial. We use synthetic division to get us the first factor, and after we knew the first factor, we had reduced the polynomial to one that we already knew how to factor. Here's a summary of today's lesson, all the things that we can do so far with synthetic division. One thing you can do is evaluate a function for a particular x value. So instead of doing direct substitution, you can use the synthetic division technique to evaluate an answer. Another thing you can do is factor. You can factor more complicated polynomials because synthetic division gives you a way to get started. Another thing you can do is find roots, which are also called solutions to the equation, and they're also called the x-intercepts of a graph. Whenever you're dividing a number in with synthetic division, if you ever get a remainder of 0, then that number you divided in is a root of the equation. It's a solution. It's an x-intercept. And another thing you can do is divide a polynomial. But remember, you can only divide if the divisor has that format right there. It's got to be like x take away 4 or x take away 6. It could be x take away -2, but it's got to look like that in order to divide using synthetic division. Here is the homework assignment due tomorrow, and if you need any help on these or you want to check your answers, I do have a solution video on my YouTube channel.